Okay, so let's look at number 3. It says a lake is mapped out according to the coordinate grid where x and y are measured in miles. Okay, and then on the lake a kayak and a canoe. So here's your kayak right here, and then the canoe are moving in, according to the parametric functions shown below. So the kayak is moving this parametric equation, and this parametric equation grouping is showing the x and y for the canoe. Okay, so we're going to write a linear for both of these. So I'm going to kind of do them both at the same time so you can compare and contrast and see how is it that we're trying to get an x and a y parametric equations to basically a rectangular form where there's no t's involved. And it's just y equals mx plus b. So there's no t's is what we're trying to do. So no t's. Okay. So step 1, what we want to do is we want to get x all by itself. So if t by itself from the x equation. So I'm trying to get these t's by themselves first. Okay. So let's go ahead and just do the algebra from there. So we're going to say x minus 13 is equal to negative 2t. And we're going to say x minus 20 is equal to negative 4t. Now dividing by the coefficients of negative 2 and negative 4, we're going to get x minus 13 all over negative 2. And we're going to get x minus 20 all over negative 4. Okay? And what we did there is we basically found t in terms of x. Okay? And we got t in terms of x over here. So what we're going to do is we're going to plug in these x terms into the second equation for y, so that we get y is equal to 16 minus 2 parentheses t. This first one we got all of this for t. And then over here we'd get y is equal to 2 plus 2 times t. And for this t value we got x minus 20 all over negative 4. Okay? And yes, you do have a calculator, but you can also type this out and simplify to see what it would give you mx plus by's. Okay? So I'm going to show you both. I want you to do it by hand and see the number, see the algebra by hand first, and then I'll show you how you could do it with the calculator just to verify your answers as far as that goes. Okay. So what I'm going to do is I'm going to look at this coefficient almost like over 1. And I'm going to multiply this negative 2 across this numerator. And then I'm going to multiply this positive 1 across this negative 2 denominator. Okay, so I'm going to do the same thing over here. I'm going to distribute this positive 2 across this numerator. And then I'm going to distribute this, this given 1, this understood 1, with the denominator of negative 4. So let's see what we get when we simplify all that out. So we get y is equal to 16. This and this will multiply to give me a negative 2x. Okay? And it's going to be negative 2x plus 26 all over this negative 2. Okay? So don't let this confuse you. It kind of looks a little bit weird because of the way the fractions are laid out right now. But what it basically is going to show is how are we going to group these as far as their signs are concerned. And if you're struggling right now to see, because this fraction does look a little intimidating per se, you could always divide the inside piece into two different fractions. Let me show you what I'm talking about. So it's like negative 2 over 1. And let's divide this into two fractions. It's going to be x over negative 2, and then minus 13 over negative 2. I think that probably might be easier to see whenever you're going to distribute all these values out. Okay? So we have a negative and a negative, which we know negative times a negative is in fact a positive. So we're going to change that up real quick. And now we're ready to distribute this negative 2 over 1 across both of these fractions and see what we get. Okay? So let's go ahead and distribute these two first. This negative 2 over 1 is going to distribute across this right here. So a negative 2 times x will be a negative 2x, and a positive 1 times negative 2 is going to be a negative 2. Okay? and we distribute this across over here, we're going to get a negative 2 times a positive 13. Okay? So that's going to be a negative 26, and then positive 1 multiplied with that positive 2, you're going to get a 2. Okay? And you can see that 26 over 2, in fact, will reduce to 13. So we can go ahead and just write that out. Okay? So we have 16. Let's go ahead and identify that a negative over negative is, in fact, a positive. Okay, so we're going to be adding this per se. And that 2 over 2 reduces to 1. So we could see that this, in fact, is going to be a positive x. It just simplified all out and canceled reduced to a positive x. So 16 plus x minus 13 would result in y is equal to x plus 3. Okay, so now to verify this with the calculator, because some of you are struggling as far as with fractions, and this might not be your forte right now, as far as to simplify this out, but we do want you to find it all the way to this point. So just to check your work, not to replace it, but to check your work, you can always input this into the calculator. Just don't press Control Enter. Okay, I know that normally y'all do the Control Enter to get a nice decimal number, but we're not going to do this in this case because we're trying to come up with an equation, not an answer like 3.85 or whatever that you're rounding to 3 decimal places. Okay, so let's go ahead and insert this part right here into the calculator and see how, in fact, it does simplify out. Okay, so let's go to the calculator. And we're going to do 16 minus 2 times parentheses control divide. And all we're going to do is put in x minus 13 divided by 2. So here we go. X minus 13 all over negative 2. And if you press enter, not control enter, you'll see that it simplifies out to the x plus 3. Control enter will give you this decimal, and it's a little bit confusing, but you only need that whenever you're looking for values of like decimal places. This is a function that you're looking at, so you don't need it for that. Okay, so for the sake of the video, I'm going to take this out and just move my final answer of this y is equal to x plus 3 right here, so that I have room for parts C and D. Okay, so there's the first part, which is the answer for part A, and now we're going to do the same thing over here. Okay. So by hand, we're going to divide this out into 2 fractions, which is x over negative 4. And then we're going to do minus 20 over negative 4. Okay? And everything else stays the same. It's still y is equal to 2 plus 2 over 1. Again, just like we did by hand, we're going to distribute this on this first one. And then we will do the same with the positive 2 over 1 distributed way over here. Now you probably already noticed there's some things that we can simplify, and we can take this negative 20 over negative 4, and we can go ahead and put negative over negative is a positive, so we'll just say positive 20 over 4, which of course is going to reduce to 5. So now 2 times x is 2x, 1 times negative 4 is the following, and then 2 times 5 is just going to be 10. So it's 2 plus this plus 10. Notice how this positive 2 will reduce with the negative 4 to get a negative 1/2, and 2 plus 10 is 12. So it will simplify all out to y is equal to negative 1/2 x, oops, forgot the x, plus 12 for part B. Okay, so let's go ahead and put this into our calculator and make sure that it does in fact simplify to that. Okay, so again, I'm going to put this right here, whoops, this part right here, into my calculator and see how it simplifies. Okay, so I might have circled that wrong over here. We're not putting y equals, we're just putting the right side of the equation and seeing what it simplifies. So here we go. 2 plus 2 times parentheses control divide, and we're going to put x minus 20 over a negative 4. Okay, so x minus 20 over a negative 4, and you see that it does in fact simplify to negative 1/2 x plus 12. Okay, so this is an understood positive 12 right here, and you can move it around and still be equivalent because those mean the same thing. Okay? Alright, so let's move on to part C. So part C says find the coordinates of the point of which these two linear equations intersect. So we want to see when is it that this line intersects this line. So if I'm looking for the coordinates, I'm looking for the x and the y. Okay? So let's solve for the x first. What I'm going to do is I'm going to set this equation of x plus 3 is equal to, let me make that a little bit cleaner, this negative 1/2 x plus 12. Okay? And yes, you can do this by hand and you can solve for x. Or if you wanted to solve for x here, let me show you real quick with the calculator. I just don't want this video to be super long. I can do solve feature, both the sides, and tell it to look for or solve for, comma, x. Okay, so let's go ahead and go to the calculator real quick. We're going to press, whoops, so let me clear this out. So menu 1.5 is a good way to start from a cleared screen. And I'm going to go ahead and put x plus 3, okay, so let's go ahead and do that. Menu 3.1 for the solve feature, x plus 3 is equal to, notice the equal sign is right below the control sign, and we're going to put negative 1/2, so control divide negative 1/2 times x, and it's going to be plus 12. Okay, so plus 12, comma x. That comma x at the very end tells you I want you to solve for that x value. So we know x is going to equal 6. Okay? So now that you know where these would intersect, you can plug this into any one of these equations so that you can solve for the y value. Okay, so that's what we're going to find right here. That's what we're looking for. We've found the x is 6, and now all we're going to do is we're going to plug that into any one of these equations so that we can get the y value, which you can see the y value would be 9. This is probably the easier one to plug in, so the point is going to be 6, 9. Okay. Let's now look at part D. It says, will the kayak and the canoe reach this point at the same time? So you want to know, will they reach it at the same time? So basically what you're going to do is you're going to solve for t and make sure that all of these t's match up. Okay? So watch what we're going to do. Let me clear a little bit up here with these equations. Just a little bit. And I'm using these equations right here just so that you know. And my goal is to find, are the times going to be the same on all of these? Okay, so watch. We have 6 for x, and then we're going to plug that in here. And we're also going to plug that in here, solving for t. Okay? And then we're going to plug in the y values. We're going to plug in 9 right here and also right here and solve for the t. And if all the t's are the same, all of these t's equal the same, then we did in fact find that they did get to the same location at the same time. Okay? So the way we're going to do this is we're going to go ahead and menu solve feature these pretty quickly by saying 6 is equal to 13 minus 2t. We're going to comma t and solve feature this. Since we're able to use the calculator, why not? And then y is going to be 9. So 13 minus 2, oops, not 13, 16 minus 2t. So 16 minus 2t, comma t. We want to see are these the same. And then we're going to do the same over here. We're going to say x is equal to 6 equals 20 minus 4t, comma t. Again, these are solve features with the calculator the way we just did with the other one. And we're going to say 2 plus, y is equal to 9 is equal to 2 plus 2t, comma t. Okay? So let's go ahead and punch these into the calculator and see what we get. Okay, so punching these into our calculator, we're going to punch the following equations to make sure that it does in fact give us the same times. Okay, so those 4 equations that we got at the very bottom, menu 1.4, okay, menu 1.5, nice cleared screens. We're going to press menu 3.1, 6 is equal to 13 minus 2t, comma t. Control enter, we get 3.5. If we do menu 3.1 for the second one, 9 is equal to 16 minus 2t, comma t, you see that we also get 3.5. And now we're going to do the bottom two. So we got 3.5 here, and we got 3.5 here. So far so good, same time. Now we just want to see, does this in fact happen at the same time over here? Okay, so here we go to the calculator. We're going to put in menu 3.1, 6 is equal to 20 minus 4t, comma t. And sure enough, whoops, I needed to do control divide, and I get 3.5. And then menu 3.1, 9 is equal to 2 plus 2t, and sure enough, you see we get 3.5 for that. So because of we know that they're going to equal the same position, because that's what we found over here in part C, but they are going to reach the same time, because as we plug in those positions, I'm explaining, as we plug in the x and y's, they all equal the same t value.